Welcome to another screencast. Today we're going to talk about theory of constraints concepts, or TOC concept, and in particular flow and the concept of constraints. Okay, here we've got a pipe and it's vertically orientated. So we've got a pipe with 6 different sections in it, and the blue dots are meant to represent water. We input water at the top of our pipe, and we're going to see what happens in terms of flow rate at the bottom of our pipe. And here's our pipe again with a little tank at the bottom, and you can see we input water at the top and the water flows down to the bottom, and we measure the rate at which the water comes out of the bottom and into the tank as the overall throughput, and that represents the throughput of the whole pipe. Now it's gravity fed, so as the water flows down, it will flow smoothly until it will hit various diameters of section, and you will see that the water is tending to accumulate prior to section D. Why is that? Section D is what we call a constraint. Now typically in business improvement we're asked to come in and fix a process. This pipe is representing a process, and we have to come in and work out and decide how we're going to fix this problem. So the first thing we need to do, as long as the amount of water exiting the pipe is insufficient to meet our market demand, then where would we start? Well, we would start at what we call the system constraint. And the system constraint, the thing that's restricting our flow of water in this case, is section D. It's the smallest diameter. And you can see prior to section D we have section C where the water's accumulating and it's starting to back up. How, and there's a question there, how would we determine how large to make section D's diameter? What do you think? Well, we need to increase section D's diameter so it's no longer the throughput, and we're assuming here that the market will accept any increase in throughput, but we can increase section D over and above any other section's diameter, and we will shift the bottleneck or the constraint of our process. So when section D's diameter is increased, the throughput of the water, the rate at which the water enters the tank at the bottom of the pipe, has increased. And the key thing is the system constraint controls the throughput of water through each of the pipe sections. So when we increase section D, what did we do here? It may not be quite obvious in the drawing, but what we've done is we've shifted the bottleneck to the narrowest diameter part of the pipe. So in this case, when section D's diameter increased, 3 things happened. We moved the system constraint from section D to section B. Okay. Throughput increased to the limit of the next constraint. So now section B constrained the flow rate. And we've started to accumulate water in section A. You can see that build up in water. So the key point is the throughput is governed solely by the throughput through the constraint. And that's the throughput of the system as a whole. So when increasing the diameter of any or all other sections, will we increase the throughput? We will only increase the throughput to the rate at which the throughput goes through the narrowest section, in this case section B. And focusing any improvement efforts on areas like section E will not actually help us, and is in fact wasted effort. And this is meant to represent often what we'd see in business improvement efforts in companies. They will go and try and implement improvements across a wide range of projects, and a lot of them are ineffective if they are not focused on the bottleneck. The bottleneck or the constraint of the process is what is key. Here's two 5-step processes. One is meant to represent mining, and one is representing a bank loan process. In the top process we can see that out of the 5 steps in our process, hoisting and then followed by the mill actually has the lowest throughput, and this is measuring tons per day, tons of throughput per day. And so if this was our business, we would be focusing our improvement efforts on the hoist. And the second one, it's each of the steps in our process has got times recorded against it, cycle times. Where would we put in our efforts? In this case, it would be in the receive and review the application step. Now, these processes are just indicative, and I've made them up, but they represent what's really happening in our businesses. So, some of the key things: identify your constraint and only focus your business process improvement efforts on that constraint, and then you will get throughput increases for the system as a whole, and therefore get some financial tangible benefits for your business. Thanks for listening.